The Shroud of Turin is one of the most studied and mysterious artifacts in human history. Despite decades of scientific investigation, no one has been able to fully explain how the image appeared on the cloth, or even what process could have formed it. Robert Rucker, a nuclear engineer with a deep interest in the shroud, over his 38-year career in the nuclear industry, he specialized in advanced reactor design, nuclear fuel safety, and statistical analysis, and published 41 technical documents for U.S. government agencies.
There's a nuclear engineer. You can go on YouTube. His name is Robert Rucker. Watch his breakdown. This guy's a nuclear dude. He's breaking down the it's insane because it's a negative image on a non-photographic material. It's linen.
Right.
Are you like 100% convinced that this is the shroud, the real deal? What first sparked your interest in researching the Shroud of Turin?
Well, this was when I was about 12 or 13 years old. I was delivering newspapers on Sunday morning. It was a large newspaper, but the Sunday paper came out with a little magazine called Parade Magazine, and it was something that was commonly done in the country at that time. And so I was growing up south of Detroit, and I was flipping through the Parade Magazine after I was finished doing my paper delivering before my parents woke up, and I noticed a little picture of the Shroud of Turin, of just the face, maybe an inch and a half high. Little paragraph to the right, and the last sentence was, many people think this was the burial cloth of Jesus Christ. And I thought, that can't be, because if that were true, it'd be so well known that everyone would know about it. Why would anyone talk about anything else? That's what I thought. But then I found some books in bookstores on the Shroud of Turin, and I bought them and I read them. So became somewhat familiar with it. Then when I graduated from University of Michigan with a degree in nuclear engineering, I was just too busy to follow up on that topic. But so it was kind of on the back burner of my life. Finally got married. After we were married, I found that my wife had seen the same picture, which is interesting. We both saw the same picture when it came out. We were both about 12 or 13 years old at the time. And so that's how we got interested in it.
What role does nuclear engineering, like your background, play in studying the shroud, and how has that influenced your approach?
Well, my background here, I was 38 years in the nuclear industry, had earned a master's degree in nuclear engineering from the University of Michigan. The two primary things I was doing nuclear analysis, computer calculations for design of nuclear reactors or radiation monitors, things like that, or shielding purposes. But I was also to some extent, statistical analysis of measurement data. And those two items, nuclear analysis, computer calculations, and statistical analysis, are key items in the analysis of the Shroud of Turin. So I'm the only person in the world that runs nuclear analysis computer calculations to solve the carbon dating problem for the Shroud of Turin. And I've also done some statistical analysis of the experimental measurements on the ratio of carbon-14 to carbon-12, which is what's used for carbon dating. So these were key items. So I feel like my background is ideally suited for analysis of the Shroud of Turin.
You have a presentation here, and you're going to go through maybe a little background of the shroud for us?
Oh, sure, yes. Well, let me go a little bit further here. I've been in shroud research. I should update this. Probably 12 years now. I started it in late 2013. My website is shroudresearch.net. Shroud is spelled S-H-R-O-U-D, shroudresearch.net. And I now have 39 papers on the research page of my website. I also organized the International Conference on the Shroud of Turin in 2017. It was held here near where I live in Richland, Washington, and the next community over is Pasco, Washington. And that's where we held this international conference. We get good attendance from all over the world, and 3.5-day conference. My goals are to explain the mysteries of the Shroud of Turin and to promote future testing of the shroud. Because the last time it was tested was 1978 and 1988. And there's been tremendous progress in non-destructive testing techniques since then. So let's go into the background of the shroud. There's two views of the shroud. The upper view here, if you went to Turin and see it when it's on display, it's only on display a few times a century. It was last on display in 2015. But what you see here, so we have two long horizontal scorch marks with 16 different patches where it was burned in 1532. It was folded up in a silver box. The temperature was high enough to melt the silver. It dripped down on one corner so that when you unfold it, it created two scorch marks. It was scorched along one side, but when you open it up, it's two scorch marks, and 16 patches had to be put in. But the front image is on the left side with the head toward the center and feet toward the left end. The back image, that's the front image. The back image is on the right side with the head toward the center and the feet toward the right side. Now, the bottom image helps you to see it because this is the camera negative view, and the photography enhances the contrast. So the upper view is lacking in contrast. The bottom view helps you out by enhancing the contrast. So you can see it better in that view. But when we look at the front view, we have a lot of detail, and I'm just going to go through this rapidly. We have the front view, and then we have the back view. And the conclusion when you study all of this is that what the image on the Shroud of Turin is identical to what you would expect it to be if it were Jesus crucified as described in the New Testament documents. So everything is identical. You can see the scalp wounds from the crown of thorns. You can see the scourging up and down, front and back. On the back, you can see abrasions across his shoulders where he carried a heavy object across his shoulders. That'd be the cross, just the horizontal. And then on the front, you can see the side wound, and you can see the arms coming down with blood at the wrists. And so it's just absolutely amazing. At the bottom, you can see in one foot, 2 nail holes. The other foot was crossed over so that the bottom nail was put through both feet so that his foot could rotate to allow him to push up and down to breathe while crucified. So that this, a forger wouldn't think of many of these details, like the angles of blood on his arm showing 2 different angles where he was pushing up and down to breathe, creating 2 different angles on his arms. Forger wouldn't think of doing that. There's many different things. A forger wouldn't think of putting pollen from a plant with long thorns around his head. Forger wouldn't think of doing that. So that this really is the authentic burial cloth of Jesus. So now how it got from Jerusalem to where it is now in Turin, Italy, this is the route that most shroud researchers refer to, that it started in Jerusalem based upon pollen, for example, on the cloth, and the impurities in the limestone dust that was found, indicating that it very well could have been from Jerusalem area. So it would have started in Jerusalem. Then before Jerusalem was destroyed in 70 AD, it was taken up to Antioch, where it went on various missions to Edessa, Turkey, and probably to Galatia, possibly referred to in Galatians 3:1. And then it went up to Constantinople, either in 540 or 944 AD. There's some discussion on that point. It was there at least until 1203. It was every Friday in the church in Constantinople. It was raised so people could see it. So starting in 692, the emperor took his image off the money and put the image of the Shroud of Turin onto the money. So the Shroud of Turin was extremely well known and highly revered, but it's now been largely forgotten. so it came into Turin, Italy. Let me just go back here. So then it went either by water or across land up to Lorraine, France, where it was shown as the burial cloth of Jesus in 1356, approximately. Then made its way down through France, was in a fire in 1532 in Chambéry, France, and then came into Turin, Italy in 1578. So this is the cathedral where it's been housed for centuries, and we were there in 2023, and in the left front corner of that church, the cathedral it's called, there is a stainless steel box which houses the Shroud of Turin, and there's a picture of it behind glass. So I should also mention that there is also the face cloth. You remember in John 20, verse 7, it's mentioned that when Peter and John went into the tomb, they not only found the backbench and other cloths, those would be the tie strips, because the word athania is a plural word that's used in the Greek text. So on the backbench would have been the body cloth plus probably various tie strips. And then separate from that was another piece of cloth that was folded or wrapped up probably on the side bench, though the Bible doesn't specify where it was. But this was the face cloth that was put onto his face after he died. Well, still on the cross, it would have been left on his face as the body was transported to the tomb. Once brought into the tomb and laid down on half of the body cloth, the person doing the burial evidently reached over, took this off his body, laid it aside, probably onto the side bench, and then wrapped the front of the body cloth over his head and down to his feet, so that this was off the body at the instant of the resurrection, and that's why it has no image on it. But it does show blood and blood component stains that are similar to those on the Shroud of Turin. So that it left Jerusalem about 570 AD and arrived he's been in Oviedo, Spain since 840 AD. It arrived with historical documentations as to where it came from. It's 33 by 21 inches. Just amazing that we still have this. This was dated to 700 AD. I'll get into that later. So let's go into just quickly the scientific testing. Two different types of testing. Three I'll mention. First of all, there was testing for the image formation by the Shroud of Turin Research Project. The acronym is STURP, S-T-U-R-P, in 1978. But image formation was their primary goal on this. This is John Jackson looking through a high-powered microscope at the Shroud of Turin. He was the leader of the STURP group. The STURP's conclusions, because, so what did they decide? What does science indicate regarding how the images are formed? Well, the image is not due to paint, dye, or stain, because there's no pigment, no binder, no brush strokes, no clumping of fibers or threads, no stiffening of the cloth, no cracking of image along fold lines. The images are not due to any liquid, because there's no capillarity soaking up of any liquid. It's not a scorch from a hot object, because there's no fluorescence under ultraviolet light. And it's not a photograph, because there's three-dimensional information encoded into the two-dimensional images, meaning that you can back out a statue based upon the information that's encoded into these front and back images on the shroud. So this is a picture of the tip of the nose where the image is the strongest. Now, do you see the tip of the nose? Well, no, you really don't. What you see here is you see just the top 2 or 3 layers of fibers discolored just a little bit with a straw yellow or sepia color. Now, that color is consistent with a scorch, but these fibers that are discolored, they're not scorched across the entire diameter of the fibers, which would be the case if this coloration was caused by a hot object. So it looks like a scorch because of the color, but it's not a scorch by contact with a hot object. So, and the reason for the strangeness of this, it's the strangest thing, most difficult thing to explain, is the fact that on each fiber, which is 1/5 the diameter of a human hair, and there's about 100 or more fibers in a thread that make up the Shroud of Turin. But on each fiber, 1/5 the diameter of a human hair, scientifically, measurement would be 15 micrometers diameter. This discoloration is just around the outside circumference of the fiber. Now, how in the world would you do that if that was assigned to you as a project? How would you discolor a flax fiber on the order of 0.2 to 0.6 micrometers thick with the inside not discolored? Well, I had to think for weeks on this before I could come up with a mechanism to actually do this. And we'll go into this a little bit further. Okay, so the nature of the images, well, we have full size because this cloth is 14.5 feet long, approximately, by 3.5 feet wide. So that they're full-length images of front and back of a man that was crucified exactly as Jesus was crucified. And according to the STURP research, the images are not caused by pigment, scorch, liquid, or photography. So what caused them? We'll get into that. So the images are negatives. That is, the light and dark areas in general have been reversed. And there's no image of the side of the body or the top of the head. That means that the mechanism which created the front and back image were vertically oriented. Okay, because there's no side image, there's no top of the head image. And there's generally a good resolution in the range of maybe 4 to 5 millimeters resolution. But it's extremely superficial, just surface effect. Like I said, it's just the top 2 or 3 fiber layers are discolored, and the discoloration on the fiber is just around the circumference. And the image contains 3-dimensional information related to the vertical distance of the body from the cloth. If you can imagine that. How in the world was that created? So then in 1988, the samples were cut from the shroud and sent to 3 different laboratories. And those laboratories cut those samples into 12 subsamples that were then carbon dated. The report came out in a document, and I'll just show you a page. This is it. Read it many, many times. And this is 9 pages long. The title is Radiocarbon Dating of the Shroud of Turin by P.E. Damon plus 20 others. So this document is also often simply called Damon. It was published in the highly respected British scientific journal Nature, February 16th, 1989. And in this document, it says that the mean or average dates, the uncorrected mean or average date of these 12 subsamples was 1260 to plus or minus 31 years AD. But then they had to correct it for the change in carbon-14 concentration in the atmosphere, so that the corrected date then was 1260 to 1390 AD. And that was dated to give a 95% confidence in this range, 1260 to 1390. But that 95-degree confidence would only apply if this 1260 plus or minus 31 were known with precision. And I'm claiming we ought not to trust that value. So that their conclusion, based on this 95% confidence to 1260 to 1390, was that the shroud is medieval. But those of us who were very familiar with the shroud said this cannot be the case, based upon all the other evidence involved. So shroud researchers never believed the carbon dating. Okay? In general, leading shroud researchers. Now, because there's probably about 13 different date indicators that contradict with this date of 1260 to 1390. Now, I won't have time to go into all those other date indicators. I'll mention just one. There's a side strip about 3.2 inches wide on the side of the shroud. It was evidently original material that was connected to the shroud, but it was evidently cut off and then re-sewn back on. But the stitch that was used to sew it on is evidently a 1st century stitch because it's consistent. It's only been shown to be consistent with this special type of stitch on a fabric from Masada that was destroyed about 73 AD. So the stitch dates it to the 1st century. So that's the type of thing that I'm referring to when I'm saying date indicators. But we also have new dating techniques that were invented specifically to date the Shroud of Turin. And what I'm showing up toward the right there, and what we have on the x-axis on the left, it goes from 500 BC up to 2000 AD on the right-hand side. And toward the right, you have a vertical column coming up for the carbon date, 1260 to 1390. But the time of Jesus is more toward the left. It's also in the, I'm not sure what color you call it, kind of the pinkish color coming up. That'd be about 33 AD is, I think, the modern concept of when Jesus' death occurred. But on the yellow items, you can see dates that were obtained and the one standard deviation uncertainty on each measurement, all 1, 2, 3, 4, 5 of them. 2 of them were mechanical testing on the wrist or the pelvis. So there's actually 4 different dating techniques, and one of them was done on 2 different locations. But you can see that these all contradict the carbon dating, and they're consistent with the time of Jesus, 31. The most recent and maybe the most accurate here is the Waxus date, WAXS, and that's the date, that's the uppermost date there, WAXS. It's 80 AD plus or minus 75 years, and that's it consistent with the time of Jesus. So the modern dating techniques contradict the Shroud of Turin and are consistent with the time of Jesus. Now, these are new dating techniques and do not have a long history of use of dating fabric, and we'll have to wait for other dating techniques to confirm their accuracy. Okay? So that, how do you sort all this together? Well, what you do is you get the experts on the Shroud that are doing research on the Shroud of Turin. You get them together on conferences. So that's what we have coming up. There's an international conference on the Shroud of Turin, July 30th to August 3rd, 2025 in St. Louis. And the website is shroud2025conference.com. I'm going to be making 2 presentations on Friday, August 1st. My title is Neutron Absorption Explains the Carbon Dating Consistent with the Authenticity of the Shroud. And then on Saturday, August 2nd, I'll be speaking on the VCRB Hypothesis. That stands for Vertically Collimated Radiation Burst Hypothesis for image formation on the Shroud. This concept, this hypothesis, is the only hypothesis that's been proposed. It's consistent with more than one mystery. Now, this is consistent with both the carbon dating and the image formation. So let's go into carbon dating issues now. Just a little bit of background. The human body is composed of organs. Organs are made of tissues. Tissues are composed of proteins. Proteins are composed of molecules. Molecules are composed of atoms. Atoms are composed of neutrons, protons, and electrons. So the vast majority of the mass of an atom is in the central area called the nucleus. Now this picture shows a carbon-12 atom. 12 because there's 6 protons plus 6 neutrons makes 12 items in the nucleus of the atom. So that the protons are positively charged. So that gives a positive 6 charge in the nucleus. So there has to be 6 electrons, each negatively charged, circling around it. The neutrons have no electrical charge, so that the neutrons are highly penetrating when they're emitted from an atom, so that they can travel long distances through matter. But the protons penetrate only a very short distance because they are electrically charged and interact with all the electrons of the surrounding matter. So this is the nature of an atom. So let me just talk to you about what my neutron absorption hypothesis is. To get this up front here in our discussion, so that what I'm saying is that, and this is my solution to the carbon dating problem for the shroud. What is the carbon dating problem? Well, Jesus died about 33 AD, yet carbon dating dated the shroud to 1260 to 1390. That's the problem. So my hypothesis to explain this is that neutrons were included in the burst of radiation that caused the images. So the carbon dating and image formation result from the same event, so that they're related. You cannot properly understand the carbon dating unless you understand how the images were formed. Now, a small fraction of these neutrons were absorbed in nitrogen-14 in the shroud to produce new carbon-14 atoms. Now, in the red is the formula here. Carbon-14, that would be 14 neutrons and protons in the nucleus. You add a neutron absorbed into the nucleus, it then ejects a proton. And when that happens on the right side of the equation, you produce a carbon-14 atom plus the proton that's emitted. But this adds carbon-14 to the cloth, and this caused the shroud to be carbon dated younger than its true age. You could call this a systematic measurement error. So that's my neutron absorption hypothesis. Now, where did they cut the samples from when they cut them in 1988? On the end of the cloth with the front image, they were cut from the upper left-hand corner if you hold the image horizontally. So this was cut down by the feet, but at the extreme edge of the cloth, so up at the corner. So this is my diagram showing that we have the main shroud, we have the side strip at the upper right hand. To the left, upper left is the backing cloth that shows, because that at some unknown time in the past, that tore off, probably because that's where it was held when it was exhibited. Both corners had torn off. But you can see here where the cuts were made, and then on the right-hand side of the cut, A1 was the sample that went to Arizona. Z went to Zurich, O went to Oxford. They then realized that A1 is a little bit smaller than the samples going to Zurich and Oxford, so they cut another sample called A2. Now, I showed this on the right-hand side of this left-hand piece. It should probably be on the opposite end. Should probably be on the left-hand side of that other piece. But that's where they came from. And when the measurements are done on those different samples, you remember each laboratory cut their samples into subsamples. So we had 12 subsamples. The values that would come out would be, you get two values from each experiment. You get the value and the uncertainty. Well, what is this uncertainty business? Okay, so on this diagram, we try and explain that. The vertical line on the right-hand side is the true value, let's say. But the measurement is the curve. This would be called a bell curve. So the dashed vertical line is what the actual measurement that's reported. And so the width of that distribution, if you repeated the measurement over and over, you get a distribution as shown by the solid bell curve line. But due to random error, you get various answers in your experiment. So that's the random error is related to the width of that curve. Now, there's also called a systematic error, where you can have an error that causes all your measurements to be wrong. So that's what the systematic error here is. Their horizontal arrow then shows the difference between the dashed line, which is the experimental value, and the solid vertical line to the right, which is the true value. So each measurement, then you have a value and the uncertainty, and that's what we have here. So Oxford had 3 measurements, 3 subsamples. Zurich had 5 subsamples. Tucson produced 4 subsamples, and on each one, we have a measurement. For example, Oxford, the upper value is 1155. That would be the year AD, 1155, plus or minus 65. So you see there, Oxford has 1155, 1205, 1220, for example. And in the green values below, I show you the values that are shown in Damon. You remember the report that was produced in Nature in 1989. The green values are just right out of this report. So the Oxford average is 1200 plus or minus 30. The Zurich average is 1274 plus or minus 24. The Tucson average is 1303 plus or minus 31. Well, what do you notice about those values? They increase from Oxford to Zurich to Tucson. Where were those three samples located? Oxford was toward the left, Zurich was in the middle, Tucson was to the right. So the older value was produced at the end of the samples that were closer to the short end of the cloth. And as the sample area moved further toward the center of the cloth and the center of the body, then the date increased. Very strange. They should be the same. So in other words, if you take the value from Tucson and compare it to the value of Oxford, these two values are statistically different from each other, as though they were dating two pieces of cloth from different sources. And that should not be the case. Now, when I did the analysis, I redid their analysis. I should be able to calculate exactly the values that they gave. So you can see in red are my calculations starting from the same values that they listed above. And so for Oxford, I obtained the same values. Now, I'm listing one additional digit here just for precision. Not that it's necessarily statistically significant, but just for comparison's sake. So Zurich, I'm in agreement with Zurich's value, but Tucson, this is quite different. Now, the value itself is very similar, but the uncertainty is very much different. My value was 17.1. Damon's value was 31. Why in the world was that difference? Something strange is going on. Now, again, when Damon takes the three values from the laboratories and averages them, he gets 1260 plus or minus 31. Well, I get 1277.8 plus or minus 12.6. The uncertainty is much different. Now, you can't just throw out the uncertainty because the uncertainties tell you how the value should be interpreted. So they're both important, equally important, I would say. If you don't have the uncertainty, you really don't know what the value means. Okay, let's go on. So if I take the three values from Oxford, Zurich, and Tucson, and if I were to locate them at the center of each of the sample and measure it from the distance from the short end of the cloth on the left-hand side, and then plot the results, this is what I get. Now, let's go over the details of this. So on the x-axis at the bottom, it has the distance from the short end of the cloth. That's in centimeters. And the y value on the left-hand side is the carbon date that would be produced. That would be the measurement that would be obtained. Okay, now, let me explain a little bit further. Yes. So this is just plotting the measured values from the three different laboratories. So what Damon did was that they took these three different values and simply averaged them, thus producing the dashed black line at 1260 AD. But as you look at the data, my red dashed line fits the data much better, doesn't it? That's because I think there was a systematic measurement error. So each of these red values that are plotted, the diamond shape is the actual value, and then the vertical line is the one standard deviation that's plotted. So the red dashed line goes through the data much better. So now when I take this same data and then I do a nuclear analysis computer calculation on a human body wrapped in a linen cloth in a limestone tomb as it would have been designed in first century Jerusalem. And then if I assume that in Jesus' resurrection, there was also a burst of radiation involved in it, evidently not the main thing going on, but this was also going on. Burst of radiation that included neutrons, so that neutrons were emitted from the body. Under those assumptions, I set up the model in my computer code called MCNP, which is an acronym for Monte Carlo N particle, produced by Los Alamos National Laboratory, probably over a period of 5 or 6 decades, worked on by probably 12 to 15 people on the average. So this is a standard nuclear analysis computer calculation or code that's accepted and been fully validated and verified to standards set up by the federal government for computer accuracy. So when I do that calculation, this is what my result is. So on the x-axis, I'm again showing centimeters, and this would be along the backbone, essentially underneath the body. This would be on the dorsal image, on the cloth, under the body, so that this is the carbon-14 date in the shroud below the body. On the left-hand side is my nuclear analysis computer calculation of what the carbon date would be if they were to take a sample at each point along the center line underneath the body on the dorsal image. So that you can see the curve there. It goes up to 8,500 above or under the center of mass of the body, because that's where you'd have most neutrons creating new carbon-14 by way of being absorbed in nitrogen-14. So that this curve gives you a different date for the carbon dating at each point. At every point, it would be different. Every location on the shroud would have a different carbon date. That's what we're saying. Now, to produce this curve, the computer normalized this to just emitting one neutron. Well, of course, the calculation ran through many, many different neutrons. So I had to renormalize this. And what do you normalize it to? So I had to normalize it to the experimental results of 1260. And the second point from the left would be that point. And so you can read it off at about 1260 for the second point from the left. The point of interest here is that I'm not taking any advantage, any credit for the 1260 because I'm normalizing that second point to the experimental results. But the point here is that if you look between the first and the third points, the slope across the second point is a certain value. And what value is that? It's the same value that I just showed you. In other words, my nuclear analysis computer calculations produce the same slope on the data as the experiments. And this was not this slope was not put into my calculation. This is just a result of how neutrons interact with each other and with the material in the tomb and the limestone around the tomb. So this was just a calculated value, is consistent with the experimental value. Now that's what scientists like to see. So in other words, this neutron absorption hypothesis is consistent with the evidence from the 3 different laboratories. And we'll discuss that further. So now, in evaluating a hypothesis, a scientific hypothesis, there are certain criteria that should be used. Now, this is my paper 37 on my website, shroudresearch.net. So, the criteria First and most important is that the hypothesis must be consistent with the evidence and with all the evidence. If the hypothesis is not consistent with some aspect of the evidence, then it cannot be true. Secondly, the hypothesis should make predictions that are testable and falsifiable. Testable in a sense that it's falsifiable. Now, what that means is the test should be capable of proving the prediction wrong in order to falsify the hypothesis. So if the test can't be capable of proving the prediction false, then what good is it that if it proves it to be true? You have to have capability to prove that it's either true or false. So that unique predictions are desirable. Now, unique means a prediction made only by that hypothesis. And my hypothesis makes predictions that are unique because every location on the shroud is predicted to have a different carbon date. Now, a third level criteria, and these, the first level is a must, the second level is a should, and the third level is a preferred. And I have several different possibilities here, but I think the most important of the preferred items are that the hypothesis explains multiple mysteries, which my hypothesis does. It explains both carbon dating and image formation. And it's the only hypothesis that does explain more than one hypothesis, more than one mystery of the shroud. So where we are now on how does my hypothesis of neutron absorption, then how does it explain the evidence? How consistent is it with the evidence? So my hypothesis says that the body had to emit about 2 times 10 to the 18th neutrons to shift the carbon date from about 33 AD to the range of 1260 to 1390. So the average of that would be about 1325 AD. So that, so my hypothesis is consistent with that because I normalized the whole distribution to that amount. So the experimental data just informed me how many neutrons would have to be emitted to shift the carbon date from 33 AD up to about 1335 AD. So the curves that I just showed you, number 2, also indicates that the dates depend on the location, which is strange, or something like this, with a slope of about 36 years per centimeter, which is about 91 years per inch. In other words, if you move the sample point up 1 inch, you'd get a change in the carbon date of about 91 years. If you moved your sample point up 10 inches at this rate, it would increase the carbon date about 910 years. So the shroud would then date to the future. So it'd be very clear that there's something wrong at that point. So number 3 here is the distribution and range of the dates for the 12 subsamples. Now, this is something that I couldn't solve previously when I was previously working on this in 2014. But I'm now restarted this issue, and I'm now working on this issue. But also in number 4 is that the Sudarium of Oviedo, the face cloth of Jesus, was dated to about 700 AD. And I thought, let's see if this is consistent with my neutron absorption hypothesis. But the problem is that we're not told in the Bible where it was located in the shroud. But then it occurred to me, I bet I can predict where it would have been placed. The person doing the burial would not have thrown it behind him or back over in another corner or someplace. No, he'd simply drop it about level with his body. Not on the floor, that's where he's walking. He wouldn't have been placed it on the walls or the ceiling either. Would have dropped it on the side bench. And his body would be about 15 to 18 inches toward the entrance of the shroud. That would be in front of the back bench where the body was located. And so that's where I predicted that the shroud would date to about 700 AD. So I didn't have shroud material in my computer calculations on the side benches, left bench or right bench. So I had to rerun the calculations, took about a week. Finally got the results out, and I looked where I had predicted that the face cloth would have been dropped. And when I looked there, the carbon date that the computer code gave was 700 AD, in agreement with experimental results. So I'm doing something right in doing all this. Now we go to back to number 3, is the distribution and range of the dates for the 12 subsamples. The problem in analyzing this is that the laboratories, the 3 laboratories that cut their sample into subsamples, evidently, never been reported, evidently did not record how those samples were cut into subsamples. We don't have that information. So I have to make a prediction how the laboratories cut the samples into subsamples. And this is my prediction, taking everything that we know about the subsamples. This is my prediction. So, locations for the 12 subsamples. Now, on the x-axis, these are the dimensions of that right-hand piece that was cut from the Shroud of Turin. It was about 3.8 centimeters long. So, on the x-axis, it goes from 0 centimeters on the left side to about 3.8 centimeters on the right side. On the y-axis, it was about 1.6 centimeters in that dimension. So on the y-axis, it goes from 0.0 centimeters up to 1.6 centimeters. I also include the other points where my proposals for where they were cut are located. So in there's 12 different subsamples. There's also 2 different reserved pieces that were evidently kept for Zurich and Tucson. I label these as number 13 and number 14. We believe that 13 is no longer available, having been thrown out. But number 14 should be in the vault in Turin, Italy, and should be available for future testing. But on each of the other regions, the 12 regions for the subsamples, I list a number. So from left to right across the top, I have regions 1, 2, 3, 4, and 5. Across the bottom, I have regions 6, 7, 8, 9, 10, 11, and 12. Next to that number, then, back up on the upper subsample for Oxford, I have number 1, 0, 1.2b. So that's the laboratory designation for this sample. The O stands for Oxford, Zurich used Z, Tucson used A for Arizona. So that we then have the laboratory or the subsample number, the laboratory designation, and the carbon date that was obtained by the laboratories. For the top subsample from Oxford, it was 1220 plus or minus 45 years. So the 1220 is the date AD, so that I include the carbon date for each one of these. So my project that I'm now working on is to run enough neutrons in my model to get the predicted calculated date accurate enough to be very comparable to what the experimental value is. In other words, I want a very small uncertainty. I want the uncertainty to be down probably in the range of 1 or 2 years, if we can do that, so as to make the calculation, the uncertainty in the calculation, insignificant, so that I hope to prove that my calculation, based upon the neutron distributions in the tomb, will obtain the same dates as the 12 values on the 12 subsamples, as shown here. So that's to be completed. So I'm sorry I couldn't report the conclusions of these calculations. I just haven't finished them yet. I've been working on them for a few months so far. So are there any questions at this point?
Oh yeah, I got all kinds of questions. Maybe we could do it after you present.
Okay, let's go into image formation. So let me just back up one. This is the new item that's going to be presented, and hopefully my results in doing this calculation will be presented at the conference in St. Louis. And I hope that this will be understood to indicate that the carbon dates, the range and distribution of the carbon dates, result from the neutron distributions in the tomb. So that should help people understand that other proposed causes of the carbon dates are not necessary. That it's fully explained by the neutron distributions in the tomb. So let's go into image formation, and I have one new item on image formation that will be discussed on the Shroud of Turin at the conference as well. So let me just go through a quick summary of some of the options that have been proposed for image formation on the Shroud of Turin. So this is talking about how were the images of the front and back of the crucified man that was crucified exactly as Jesus was crucified, how were they formed on this piece of cloth? Well, the STIRP experimental analysis done in 1978 indicated their conclusion that it's not due to an artist or forger, that it's not by pigment, scorch, liquid, or photography, and all attempts to duplicate these images have failed, usually macroscopically, large scale, and always microscopically, very small scale, and that it's not by contact. The images are not formed by contact, because the image on the cloth were not in. There are images on the cloth where the cloth was not in contact with the body. For example, the tip of the nose. If the cloth was laying across the face, it would have been in contact with the tip of the nose, but not in contact with the nostrils coming down. Yet we still see an image as you come down the nostril. And so there was a communication from the body to the cloth across the air gap that discolored the fibers on the cloth down the nostril. Now, I believe that the cloth was not actually on the tip of the nose. It was actually elevated above the face because, and I think that's necessary, because on the cloth, the image of the face is about the normal image of the width of a face. But if the cloth were laying over the face and wrapped around the face, then when you unwrapped it, it would be much wider than the face. So the cloth had to be elevated above the cloth due to electrostatic effects. I'm not going to get into that deeply, but I think that's the cause, and I'll mention it once later on. So it's not due to contact, due to smooth gradation of color on the shroud. If it was just due to contact, it would either be black or white, 1 or 0. There would be no smooth gradation. Now, next, it was not by random motion of molecules, because a random path of molecules contradicts good resolution of the molecules. And a path of contradicts good resolution of the images without the side images. In other words, if it was just due to random motion of molecules, that random motion, it just each time it bounces off an atom in the air, it's a random direction. So you'd lose all resolution and you would be creating side images as well. But we don't see that. So it's not due to random motion of the molecules. And it's unlikely by any natural or normal process. I think this is a reasonable conclusion, because just think of the billions of people that have lived and died. They would wear clothing during life in general, and when they died or at night, they'd be laying underneath a cloth. Now, I've looked through my dresser, I've looked through my closet, and none of my clothing has an image of my body on the inside of my clothing or under any of my sheets I lay under. No, there's no images. The Shroud of Turin is the only cloth with these characteristics. In all the billions of people, you would expect this to have happened many times if this was a natural or normal process, but it wasn't. So therefore, I suggest that we should expect this these images would be due to a process, an event that is outside of our current understanding of the laws of physics. That's how I would say it. So, what is required to form the images on the shroud? We have two things. We need a mechanism to discolor the fibers. Then we need energy to drive the discoloration mechanism to discolor the fibers. But most importantly, and what's usually just totally left out, people aren't aware of this, you must have information to control the discoloration mechanism. That is, to discolor only the right fibers with the right length of discoloration. There has to be an information flow from the body to the cloth, because where was that information that defines the appearance of a crucified man? Where was that information? It was not in the air in the tomb. It was not in the limestone around the tomb. Where was it? It was only in the crucified body. And that's why you could see the crucified body, because photons then of light would reflect off the body, go to your eyes, carrying the information content that defines a crucified man. And that's why a person in the tomb could see the body of a crucified man. Same thing when you open your eyes and you look around you. Why do you see the images around you? It's because photons of light reflect off everything in all different directions, including some that go into your eyes, carrying that information content. When those photons go to the back of your eyes, they're absorbed on rods and cones in the back of your eyes. That information content that's carried to your eyes on the reflected photons is then translated into and to be carried by the electrical signals that move up your optic nerve to your brain, and your brain has learned to interpret the information content on those electrical signals as the items in the scene around you. So that information carried on radiation, that's what photons of light are, it's radiation. Information carried on radiation is the main way that information comes to your body. Probably over 99% of all the information comes to your body based on radiation that enters your eyes. Next would be sound waves entering your ears, much less information from your nose or your taste. And then the fifth sense would be touch, of course. So you need mechanism to discolor the fibers, energy to drive the discoloration mechanism, and information to control the discoloration mechanism. So what I did in my paper number 34, and if you want the details, you can go to my website, shroudresearch.net, go to my paper 34 on the research page. That's the third page over. And just click on it, and my paper will come up, and you can download it from that point. So what I did, and I think this is a unique innovation in my development of my image formation hypothesis. All other image formation hypotheses that I'm aware of always were done in a top-down fashion. Now, what I mean by that is that they would think of, the person doing the hypothesis would think of a way in which the fibers could be discolored, and then proceed with that and maybe investigate some of the evidences. Whereas I did it from a bottom-up approach, where I started with the evidence and analyzed each evidence as to what it meant for the requirements that had to be met for the image formation hypothesis. So I had these 7 image evidences. I had these 16 evidences, 8 through 16, that I considered. Then I considered these evidences, 17 through 23, and then I also included these evidences, 24 through 27. So I analyzed each one at a time to develop the requirements that were necessary to explain the images on the Shroud of Turin. Now, the conclusion here is that images were formed by radiation, and that is the conclusion of the leading shroud researchers. So that And you can understand part of the reason for that is a smooth gradation of color as you come down the nostrils, as well as other places on the body. It has to be communicated across the air gap, and it has to be communicated in a manner that is consistent with a good resolution of the images. So I'm not really sure how you can come up with any other conclusion that it had to be from radiation, because radiation can travel in a straight line. That's the reason for it. That was my initial reason for it. So radiation communicates information. So all the color shades and positions of every item that you see, every point on every item that you see in front of you, as you open your eyes, is communicated to your eyes based upon the radiation of photons of light. And this is why we can see. It's just like photons of light were designed for the purpose of communicating information to our eyes. Our eyes were designed to receive it and interpret it. Fascinating. Secondly, absorption and scattering of the radiation as it goes through the air can explain the smooth gradation of color, why the images are negatives, why the 3D information is in the images, why the front and dorsal images have the same characteristics, so that it can automatically explain many different features. Now, so as I've discussed before, the information was inherent to the body, so that the radiation had to be emitted from the body to carry that information to the cloth, carrying that information across the air gap between the body and the cloth. So that, well, how was the radiation emitted? Well, paper 34 will take you through the entire reasoning that I went through in this process. But if you're talking about protons, neutrons, and electrons, which I think is what we're dealing with here, because I had to get charged particles, I think, were the actual cause of the radiation. But how do you get charged particles? In particular, protons, how do you get them? Well, they're in the atoms in your body. So you have to add some atoms in your body to split to release those charged particles. So that, how is that to happen? Well, my conclusion is it's not due to other collision with other particles. No, it's due to a vibration of the nuclei, and a vibration of the nuclei, the atoms, the nucleus in the atoms was so violent that it essentially tore the nucleus apart. In the liquid drop model of the nucleus, there's consideration of vibration splitting of the nucleus. So I'm suggesting that there were vibrations of the nuclei. And what would cause that? Well, the nucleus is positively charged. So that therefore the most obvious explanation would be an oscillation of an electric field in the tomb. Now, this electric field would have to be vertically up and vertically down, oscillating between the two. Vertically up, vertically down, up, down, up, down, up, down, etc. So that both the front and the back images were formed simultaneously. But in that process, the nuclei were vibrating, and what isotope would split under those conditions? Well, no, and the isotope is an element an element has a certain number of protons in the nucleus and then a certain number of electrons to make the atom electrically neutral. But it can have different number of neutrons. So an isotope is referred to as the type of element that has a different number of neutrons in the nucleus. So that I'm not going to go into the details of it here, but the nucleus that requires the least energy to split, that is the least amount of vibration to split the nucleus, is deuterium. Now, deuterium is also called heavy hydrogen. It only has one proton in the nucleus, so only one electron circling it, but it also has a neutron, and it's a very small minority of the atoms in hydrogen have a proton as well as have a neutron as well as a proton in the nucleus. So I'm predicting here that it was deuterium, nuclei that split, thus releasing a neutron that shifted the carbon date and a proton that formed the images. Okay? So, and that's the first bullet point here. H2, that's deuterium, is the isotope that requires the least energy to split, so it's most likely to split. Splitting is endothermic, not exothermic, so you have to put energy into it. You might think, well, this is fission, which it is, but it's not releasing energy in this case. And I'm not going to go into the details of why that's the case. So splitting is endothermic. You have to put energy into it to cause it to split. And that's where the vibration comes from, to add energy to split it. It requires to be energy to put into the nucleus to split it. It does not result in a nuclear explosion. How many neutrons? Well, about 2 times 10 to the 18th is what I said before. Nuclei must split to release 2 times 10 to the 18th neutrons, which is required to shift the carbon date from about 33 AD to the range of 1260 to 1390 at the location from where the samples were cut in 1988. So, if 2 times 10 to the 18th deuterium nuclei split, were there that many in the body? Well, yes, there were. That would require only 0.0004% of the deuterium nuclei that were in the body to split. So, what we also conclude here is that we had an extremely short radiation burst in this process. We can conclude that from the evidence. This is indicated by the extremely thin discoloration layer around that was on the outside of the fiber circumference. This is often quoted as being about 0.2 micrometers out of a 15 micrometer diameter. But I don't think it's ever been measured. I think those who have tried to estimate it, they'd estimate it a little bit larger than that, in the range of 0.6 to 0.8 micrometer 6, still very thin around the outside circumference. This extremely short radiation burst is the only thing that is outside of our current understanding of the laws of physics. Now, let me back up here. The point here is that this very thin discoloration around the outer circumference of the fibers, it could only be produced if the heat deposition was extremely rapid. A slow heat deposition, like, for example, from a hot object, would discolor the entire radius of the fiber, which is not the case. So it had to be very quick burst, maybe down in the microsecond, maybe down in the nanosecond range. But this extremely short radiation burst is the only thing in this whole scenario that is outside of our current understanding of the laws of physics. So in other words, what I'm saying is that what I'm doing is that I'm recognizing that there was an event that's outside of our current understanding. But everything after that event followed according to the laws of physics as we currently understand them. And that's what my nuclear analysis computer code is doing. So I'm not explaining everything. I'm explaining everything except that one extremely rapid radiation burst. So I'm not explaining the resurrection. I'm explaining results of the resurrection, I guess you'd say. So all subsequent processes are within our current understanding of the laws of physics. So the radiation also had to be low energy radiation. So now this is evidently an evidence because you can tell that there was not a burst of high energy radiation emitted from the body, because that would have left an increased number of radiation tracks in the fibers by the atoms that have their electrons knocked out of them. They actually leave a pattern, a path, as they're passing through the fibers. But we don't see that. The image fibers in the image have about the same density of radiation tracks as the fibers that are not in the image. So that, therefore, the image of this radiation burst had to be below the minimum energy required to ionize atoms in a fiber. In other words, this is a threshold event. There's a threshold. Below this energy, there are no radiation tracks produced, but above this energy, there would be. So where is this threshold? It's in the range of about 10 to 30 electron volts. Now, what is an electron volt? An electron volt is the energy that an electron would have if it were accelerated across a voltage difference between two plates of 1 electron difference. So if you had a positive charge and a negative charge, and the charge on those was 1 volt difference, and the electron was accelerated across that distance, the energy that it have when it hit that other plate would be 1 electron volt. Now, we normally talk in terms of million electron volts. Now, this is where the new evidence comes in. So I calculated how much energy a proton would have to have in order to cross a 3 to 4 centimeter air gap and make it to the cloth in order to discolor the cloth. Because at air gap distances larger than about 4 centimeters, any radiation from the body, the evidence is that it has not discolored the image, so that it would only go about that far. So what is the energy of that protons would have to have if they moved through air to go about 4 centimeters? Well, the answer is greater than 1 million electron volts. It's up in the range of about 1.3, 1.4 electron volts. So my conclusion there is this vertical motion of the protons cannot result from the protons being emitted vertically. Now, that's contrary to my paper 34. This is the new evidence, the new conclusion that I've come to just in thinking about it more and interacting with other people. So that how is this radiation essentially vertically oriented or collimated in the vertical direction where it's basically moving upward or downward and not like this in all different directions? So it's not due to the particles being emitted in a vertical direction. Okay, let's look at the other option. There is another option. So that if the protons were emitted with an energy below this threshold of 10 to 20 electron volts, it would have an extremely short penetration distance into air. And I forget the value. I've calculated. I forget it right now, but it's extremely short. So that it would only go that very short distance, knocking electrons out of the outer orbits of the air as it passed through. And then the energy would be exhausted. So you'd have a little corona discharge at that location. So how are those particles, they've already lost all their forward momentum then, how do they make it across 4 centimeters to get to the cloth? Well, the answer is the electrical oscillation that I'm also postulating has to then carry them and accelerate them across that gap. So I've totally changed that bottom line conclusion in my paper 34. So I have to go back and I have to revise my paper 34 to include that new information, that new conclusion that I've now come to, which will also be presented then in our Shroud conference in St. Louis. So let me just read through the vertically collimated radiation burst hypothesis for image formation. Now, this is a conclusion of my analysis of my 27 different evidences in my paper 33. An extremely brief, intense burst of vertically collimated, not collimated by how they were emitted, but vertically collimated by fact of the nature of the electrical field, vertically collimated radiation was emitted in the body that rapidly oscillated between vertically up and vertically down directions. This consisted of charged particles, probably protons, that caused an oscillating corona discharge from the top fibers facing the body that caused a high-frequency alternating current in the fibers that deposited heat in the thin outer layer of the fibers to discolor them around the circumference of the fibers to form the image. A long sequence of cause and effect. I'm sorry for that. This is complex because the evidence is complex. Okay? Now, one thing here that's important. I'm talking about an alternating current. These protons that are emitted forming an alternating current in the fibers. What good is an alternating current in the fibers? You go over and you turn on the light switch. The light goes on, but what goes on the wire? What's going on in the wire between your switch and the light? It's alternating current. That is where the electrons are going back and forth. They're not just going in one direction. That's direct current. If they're going back and forth in the wire, that's alternating current. Now, when I thought back to my first year of physics at the University of Michigan, we learned about what was called at that point the skin effect of an alternating current. Skin effect. Now, it's not referring to human skin. It's causing about the surface effect of a alternating current. So what an alternating current does is that this oscillating back and forth motion of the electron in the outer perimeter, outer circumference of the conductor as it's flowing back and forth like this, flowing back and forth just on the outer circumference. It creates and destroys oscillating magnetic fields which push the electron flow to the outer radius, exactly where the fibers are discolored. So that's my concept here, that there was an alternating current in the fibers, and under extreme conditions, even what you would think would be a non-conductor, a flax fiber, can become a conductor under extreme conditions. And so that's what and that's a prediction that we can experimentally prove that is the case under extreme conditions. So my hypothesis is that that's how, when the electrons are flowing in the outer circumference of the fibers, they would then knock against the atoms in the fiber, causing them to move, which is heat. So that heat, electrically deposited heat, then scorched the outer circumference of the fibers, and that's why the coloration is the color of a scorch, because it was a scorch, but not by a hot object. It was because of electrically deposited heat just in the outer circumference of the fibers. So, why do we recognize the image on the shroud as a crucified man? Okay, it's because the information that defines the form of a crucified man has been encoded into the pattern of discolored fibers on the cloth. If you take a picture of your neighbor or a loved one or whatever, and you see the picture, how is it that you can see the picture? It's because the information content that defines, let's say, my wife's appearance is encoded into the locations of the discolored molecules on that sheet of paper. So it's the information is encoded into the pattern on the item, and that's what we have with the Shroud of Turin. So that because the information that defines the form of crucified man has been encoded into the pattern of discolored fibers on the cloth. Photons of light that reflect off the front and dorsal images then carry this information to our eyes. And so that information that defines a crucified man is carried to our eyes, goes up the optic nerve, and is understood by our brains. So, 3 points here. VCRB hypothesis. And neutrons emitted from the splitting of deuterium atoms then shifted the carbon date, thus explaining the carbon dates that were obtained in 1988 for the Shroud of Turin. The protons produced an alternating current in the fibers that scorched the circumference of the flax fibers. What about the electrons? Well, I didn't touch on this, well, I'll just mention it here. Electrons produced various electrostatic effects on the shroud that can be seen on the shroud. For example, I mentioned the top face cloth. The top cloth had to be above the body. The body had to be above the bottom cloth. Believe it or not, the body was levitated above the cloth. As indicated, I'm just following the evidence where it leads. The body was levitated above the back cloth because there's no flattening on the shoulders or the buttocks on the Shroud of Turin, like can be seen with a naked body laying on a glass plate if you take a photograph from the bottom. And also, for example, the hot spots on the mustache with the whiskers that are more vertically oriented, acting as little lightning rods. All these are electrostatic effects that are caused by electrons. So, application. Who is this that we see on the Shroud of Turin? There's two criteria that can be understood and followed to determine who this was. Criteria number one, he was crucified exactly like Jesus was crucified. So therefore, it was either Jesus or it was someone who was crucified to simulate Jesus' crucifixion. Okay, criteria two, an extremely brief, intense burst of radiation from his dead body produced the front and back images of his body and produced new carbon-14 on the cloth that shifted the carbon date. Now, if you look through all the documentation in human history, there's only one person and one event that could possibly be consistent with both of these criteria, and that the only possibility is that this is Jesus in his resurrection. So therefore, this is the first time that humanity has scientific evidence for the resurrection of Jesus. So I give you my website again. I give you my name if you want to communicate with me. So are there any questions?
All right. There's a lot to this. It's pretty crazy. So your computer code, how long did it take you to calculate that?
In 2014, I spent about 5 or 6 months doing those calculations. So each calculation with my MCNP code on my old computer would take between 6 and 13 hours, following one neutron at a time, to accumulate following enough neutrons to give me an uncertainty that was small enough to use. Okay. Now, it takes a much longer runtime. I have a new computer, much faster than the old computer. But the subsamples are much smaller than the samples. So therefore, I have to run many more neutrons. So for example, I just finished a calculation that took 9 days of it running continuously for 9 days. And it followed 2.2 billion neutrons to get uncertainties of less than 1 year on the calculated results. So, it varies between, yes, multiple hours and, 9 days. So I'm going to try and use acceleration techniques, which I'm not very familiar with, to tell you the truth, because I never had to do them in my nuclear background. I was doing other things. I was doing design work or criticality safety calculations, but not this type of calculation. So I have to become more experienced in it to accelerate it to the place where it's not wasting time on neutrons that are not going to be counted or be of any importance. Yeah, I'm saying things carefully in a certain way that at least people who are familiar with this computer code, which is a standard code in nuclear analysis, so that I'm saying things in order to help them understand how I did it as well.
Gotcha. Okay. Well, how do we know how many neutrons and protons were emitted? Does it tell you that?
Yeah. The computer code does not. I took the computer code, the data that the computer code prints out normalizes everything to 1 neutron emitted. Well, that's not very useful, right? But assuming 1 neutron is emitted from the body, it then tells you what extremely small fraction of that one neutron would then be absorbed in nitrogen-14 at the location on the linen cloth where the samples were cut from the shroud in 1988. So therefore, by using that value, a very extremely small number, I can calculate just on a piece of paper how many new carbon-14 atoms had to be produced in that shroud sample to shift the date from 33 AD, which is when Jesus died probably, up to the midpoint of the measurement data, which was 1325. Well, I can calculate how many new carbon-14 atoms I would have to produce. And then from the data that the computer code prints out, this ratio between the one neutron that was emitted and the very small fraction of that one neutron that was then absorbed, I can then determine how many neutrons would have to be emitted in the body to produce the number of new carbon-14 atoms that are necessary to shift the carbon date from 33 AD up to 1325 AD. And so that's where I come up with 2 times 10 to the 18th neutrons would have to be emitted from the body. Now, you might ask, that sounds like a mighty big number. That would be 2 followed by 18 zeros. Well, yeah, that's a big number. But that's a very small number compared to the number of neutrons that were in the body. So I calculated that as well using the weight fractions of all the different elements in a typical human body. And I came out with an answer of about 2 times 10 to the 28th neutrons. That'd be 2 followed by 28 zeros. So that only 1 neutron for every 10 billion neutrons that were in the body would have to be emitted from the body to shift the carbon date at the sample location from 33 AD up to 1325 AD, and thus explain the carbon dating of the shroud.
So there's more neutrons than protons.
Let's see, there would, in general, there's somewhat more neutrons than protons, yes. Now, the number I was quoting was I think that was about the number of protons. The number of neutrons might be 20 or 30% higher, something like that. And I know I've calculated, but I don't remember what it is offhand.
Okay. So I want to make sure I got this right, your hypothesis. So after the tomb is closed, the body of Jesus, it goes into a different dimension, like it's interdimensional travel. So the particles, the neutrons were emitted into the cloth, and then the neutrons made carbon-14, and then the particles, the protons, is what created the image on the cloth.
Yes. So if you want to know, you mentioned the other aspect here of where did the body go from their perception of reality. And I'm saying that in a certain way for a particular point. But Peter and John came in. Peter didn't recognize what was going on, but John figured it out because you remember they had Old Testament prophecy that he would rise from the dead. But I don't know if they were really focusing on that. But they did have 4 or 5 times at least Jesus told them that he would rise from the dead. But they interpreted it allegorically, figuratively, instead of literally. Because they said, this is the Messiah. He's the Messiah. He has to destroy the Romans. He has to sit on the throne of David, thus making the nation of Israel the main nation in the world. And all that has to be literal. He can't die. I mean, that's ridiculous. He must be talking figuratively. So it was John, when he went into the tomb and he saw the collapsed cloth, that he was the first one to change from a figurative interpretation to a literal interpretation of what Jesus had clearly told them. So he was the first one to believe in the resurrection of Jesus, and that was based upon the collapsed cloth, because he could logically deduce that no one had stolen the body, with this cloth still on him because the cloth was still there. No one had thrown the cloth back and just run off, during the Sabbath with this naked body, with no cloth covering it. No, because the cloth was still there. And Jesus had just not awoken in the shroud, in the tomb, and threw the cloth back. No, the whole cloth had just been collapsed after the disappearance of the body. It collapsed due to air pressure difference with a different disappearance of the body and due to gravity. Now, when John went in, there may have been tie strips. They either may be available or maybe sitting on top of the body cloth, for example, or tied around him, maybe tied around his jaw to hold his jaw up. At least that, I think. There would have been a tie strip to hold his jaw up. So that tie strip would have been left on the inside of the collapsed cloth. So those tie strips plus the body cloth is why the reference in the Greek text is to the plural number of claws. Okay? And so then my papers number 1 and 2 get into the issue of where did the body of Jesus go when it disappeared from within the burial cloth. So my paper number 1 is from a biblical evidence perspective and theological perspective. But then paper number 2 is based upon the science and the various explanations that have been given in considering each one. I think I consider 6 or 7 different possible explanations for where his body went. But the best explanation is that his body made a transition into an alternate dimensionality. Now, our 5 perceptions, we can see, hear, smell, taste, and touch, 5 senses. And based on that, we usually just assume that we're detecting all of reality. But we have no evidence for that. We actually have no proof for that. So in modern physics, for decades, they've been trying to come up with a theory of everything that explains all of the subatomic particles known to exist and all of the forces. And these theories are called string theories. And so various string theories have been proposed that explain all of the subatomic particles known to exist and the forces of nature. But it's interesting that all of these string theories, a string is just an extremely short length of pure energy, whatever that is. Okay. But these string theories, in order to explain all the subatomic particles and forces of nature, require additional dimensions to exist. They require anywhere from 10 to 26 dimensions, of which our 4 dimensions, see, we perceive 3 dimensions in space, length, width, and height, X, Y, and Z coordinate system, 3 dimensions in space, 1 dimension in time, only forward. So our perception of reality has a dimensionality of 4, whereas according to string theory, there are anywhere from 10 to 26 dimensions, so that our perception of reality, we only perceive a small fraction of the totality of reality, according to modern physics. So that's where Jesus' body went. That's the best evidence. And that's why he could return into the upper room without going through the walls, without going through the door, without going through the window. He simply popped into existence by an act of his will, making a transition back into our perception of reality from the alternate dimensionality. Now, I use the word dimensionality to refer to a system of dimensions. So our dimensionality is 4, 3 of space, 1 of time. And I have no idea how many dimensions God requires, but there's plenty in these alternate dimensions. There's plenty of room for the existence of God, angels, Satan, and demons. So a person should not reason that I don't believe in God because I can't see him. No, that's just a false assumption.
So there could be like
Any other questions?
Yeah, so like you're saying possibly too, there could be a particle that we don't even know about, that we can't comprehend.
Yes, if it's not in our physical perception of reality, then there's no way we can detect it. All of our scientific experiments have only been done in 4 dimensions. Yet there's anywhere from 10 to 26 according to modern physics. Are the best theories of modern physics. So you can't assume that our experiments have thoroughly, experienced or in being involved in all of reality. It's just a false assumption. Okay, it's very interesting where modern physics has led us. I often watch YouTube videos on modern physics, but I suspect most people don't.
So what do you think about this argument? So like radiation, it shoots in all directions. It's random. So how did this type of radiation shoot upward and like create, it's almost like a laser beam. It's like a straight up and down laser beam.
In my new realization, I've solved that problem. The realization here is that this verticality that is required for the movement of the particles was not caused by them being emitted vertically. Now, that's contrary to my paper 34. This is a new realization that I have to modify my paper 34. So that is not why these particles moved in a vertical direction. The reason is because of the vertically oriented electric field that was oscillating, that was carrying them, the particles that were produced in the air when the particles were emitted in all directions. Okay, so I know that's one of the main objections to my theory in the past, but it's no longer a valid concern. Yeah, what a scientist should do when he proposes a hypothesis, if due to people's objections, other people's recommendations, your own considerations, you should be willing to modify your hypothesis and admit that you were wrong before, at least to some extent. And that's what I've done. I've modified my previous hypothesis to bring in new evidence. That is the new evidence. What was that to get a proton to go from the body to the cloth, if the cloth is 44 centimeters away, through normal air would require an energy of about 1.3 or 4 million electron volts, which would increase the density of ion tracks in the fibers. Therefore, it cannot be the case that these protons were emitted with energies up in the million electron volt range. Okay? So we've modified our previous theory. And that's how it will be continually occur until future testing is allowed. Hypotheses are always allowed to be changed, modified, as new evidence, new considerations come to the person who's proposing it. That's how science is done. Yeah, so in other words, when I refer to a hypothesis, I'm not claiming that this is true. I'm claiming that this could be true. That's what I'm saying. And it remains to see if the predictions are validated when tested.
Well, in your opinion, are you like 100% convinced that this is the shroud, the real deal?
I have no reservations about it. Maybe that's a good way to say it. In my thinking, I have no reservations about it. Now, could I be wrong? Well, yeah, I could be wrong, but the evidence is so strong that I have no reservations about it. I'm convinced about it, and I don't want to assign a 99.9% probability or 98 or 95. I don't want to do that. I'm very comfortable in recognizing that the Shroud of Turin is Jesus and was caused by the resurrection. Now, this is how science is done, because science never proves anything. Yet people have to realize this. The layman doesn't realize this. They think, well, science proves things. Well, no. The science provides evidence to convince the majority of scientists that the hypothesis is probably true. That's all it does. Science doesn't prove anything. It provides evidence to convince the majority of science that something is probably true. Okay? So that's where I am. Yes, I believe that the Shroud of Turin is the burial cloth of Jesus, and that the image and the carbon dating were due to Jesus' resurrection as kind of a sideshow going on. The main effect was the disappearance of the body into the alternate dimensionality. But evidently that involved a vibration of the nuclei to make that transition to the alternate dimensionality. And in that vibration of the nuclei, some of the deuterium atoms, 0.0004% of them, split. That's what I'm saying.
Carbon 14.
Thank you for,
yeah, what were you say?
Yeah. So thank you for just allowing me to talk long enough to get all of this information on the table, because the further you get deeper into it, the more sense it makes.
Yeah, I mean, I think it's a very fascinating subject. And your hypothesis is unique to anyone else's. And I mean, you've dedicated a lot of your life to this, you know?
Yeah, 12 years researching on this, 38 years preparing to do the research on it.
I do have a question about the carbon 14.
Yes.
From my understanding, that's naturally produced in the atmosphere by like cosmic rays.
Yes.
Is that like the only other? Is that like the only other instance that's naturally produced?
Oh, I don't know. I really haven't dealt with that. There probably could be some other things, but carbon 14 is important because that's in any living organism. In eating, in breathing, you're bringing in carbon, which has a very small amount of carbon 14, so that when an animal dies or whatever that had carbon in it, you could then measure the ratio of carbon 14 to carbon 12. And an assumption has to be made at that point to get a date out of the experiment. You have to assume that ratio has not changed, that ratio of carbon 14 to carbon 12 has not changed since the animal died, for example, until today. And if that assumption is true, then it's legitimate to apply the equations to the ratio of carbon 14 to carbon 12 to calculate a date. So what I'm saying is that carbon 14 dating does not give you a date directly. It's indirect. It gives you directly what it gives you is the ratio of carbon 14 to carbon 12, which you then have to use in a series of equations to calculate the date. But those equations are not valid and therefore cannot be used to calculate a date from the ratio. If that ratio has changed after the death of the animal or the plant. So with the Shroud of Turin, what I'm saying was that the shroud was made from the flax plant. So when that flax plant was cut down, it would no longer be alive, would no longer be bringing carbon 14 in with the normal carbon, so that at that point, with no new carbon 14 coming into the fibers, because it was then living, it was now dead, so that at that point, the carbon 14 that was decaying would not be compensated by the new carbon 14 coming in. While it was alive, yes, the carbon 14 would be decaying, but it was being compensated by the new carbon 14 being taken in by the plant breathing and bringing in materials from the water in the soil. Does that clarify it?
Yeah, I think so. Some of it's hard to wrap your head around, but you care to bring up that chart of Jesus and that slope?
Oh, yes. I actually have many more slides on this. You know, I have over 300 slides on this, but we're not going to go through all those. Okay, so this was the experimental data. This is the calculated data. So what I'm saying is that if you look on the calculation here down on the left hand of these points that I've plotted, the slope between the first and the third slope is about the same as that slope on the red dashed line, so that it's in fairly good agreement with the experiments. Now, the way I phrase that, you know, I always try and be careful as to how I'm phrasing things, because the slope that I'm showing you here between the first and the third points on the left hand of this curve, that's as if the shroud samples that were cut from the shroud in 1988 were positioned along the center line of the body under the body. We don't know that. Okay? So on my new calculations, I'm trying to allow for the variations. See, anything that we don't know, I try and predict what the best option is, and often I try and bracket it calculationally. That's often done. So what I'm doing on this next series of calculations I'm trying to do now, I'm not assuming just one location for where the samples were located. I'm assuming actually 83 locations scattered at various X, Y, and Z locations in my model. And so I think I'll cover all of the realistic options in doing that. So I'm trying to calculate where the samples could have been, because we don't know where they actually were at the instant of Jesus' resurrection. I had to assume that the samples were somewhere in the tomb, and where I assumed that they were under the center line of the body, underneath the feet. Now, they could have been wrapped underneath. The cloth could have been wrapped, kind of tucked in under the feet at that point. That's a possibility. But on my new series of calculations that I'm trying to do now, since we don't know where the sample location was actually located at the instant of Jesus' resurrection, therefore, on my new calculation, I'm trying to bracket the possible range by modeling 83 different possible locations with various X, Y, and Z locations in my model. Okay, are there any other questions?
So that blue line is like near his chest, stomach area. So would you?
Yeah, the vertical?
Yeah, so you're saying that's the most neutrons that would come from that area?
Yeah. So what happens here, what I'm assuming in my computer model is that neutrons are uniformly being emitted the same at every volume within the body. Every cubic centimeter would be having the same probability of emitting the next neutron. So that they're being emitted uniformly throughout the body. But those neutrons then are emitted from the body. They go across the air gap between the body and the cloth. The neutrons will go right through the cloth. They generally don't interact. They'll go then through across the air between the cloth and the limestone. They go into the limestone, bounce around, I think about an average of about 163 times in the limestone. It's like a little billiard ball bouncing off of other billiard balls. Okay? Slowing down, doing whatever neutrons do, until probably about half of them come back out of the limestone. And they form a characteristic distribution in the tomb. And that characteristic distribution then causes the nitrogen 14 to absorb neutrons, which then change to carbon-14, which changes the carbon date. So that's why we have this distribution that you see, because of the natural distribution that neutrons take in the tomb, both before and after they go into the limestone. So that, yes, the neutron density will be about 8.5 times as great above the center of mass of his body as at the tip of his toe. Just comparing the peak of that curve to the far left-hand edge.
So if they did carbon dating today and they took a sample
Yes.
from the stomach or chest area, you would say it would be 8500 AD around there.
Well, this would be, again, this is the date for a location underneath his body. It's actually different above his body. The reason is that neutrons exiting his body in a downward direction would then be going into the limestone below him, bouncing around, coming, about half of them coming back out, and having a second chance to create new carbon-14. So the date on the backside of his body would be, underneath the center of his body mass would be about 8,500 AD. That's why these predictions are unique. No other hypothesis predicts this. Whereas a date from the front of his cloth would be, I think, about 5,000 AD. So quite a bit different. There's also differences between his right elbow and his left elbow, because on his left elbow, the neutrons are just going into air to the left of his body with his head to the right on the back bench, the way I've modeled it. But the right elbow would be next to the wall, so that neutrons would be going into the wall, bouncing around, both half of them coming back out, having a second chance to create new carbon-14 on the shroud. So more carbon-14 would be produced on the right elbow compared to the left elbow. So every location on the shroud would carbon date differently based upon the neutron distributions in the tomb, resulting from neutrons being homogeneously emitted from the body and based upon the geometry of the limestone in the tomb.
Do you think then there should be marks on the rock in the tomb?
I don't. No.
No?
I don't think so. What you would have, there is the item to test for, because the protons would be absorbed on the cloth. The protons wouldn't get beyond the cloth because they're electrically charged. They're going to be interacting with the electrons in the cloth. The neutrons would be going through the cloth, through the air, into the limestone. But when they go into the limestone, on the average, they go probably 8, 10, 12 inches into the limestone. Okay, so where are they going to be interacting? Well, mostly 8, 10, 12 inches in the limestone, I think. I need to calculate that. My computer code can do that. But the thing, so that neutrons, I don't think, are going to create any visible image on the limestone. But what they will do, they will be absorbed in various isotopes and creating various short-term, very short half-life isotopes and a couple long-term isotopes. So thank you. There you go. I didn't include that in my presentation. Yes. So that what we're talking about here is that, that's a diagram that I made of what I'm basically doing. So you can see the pit in the middle. You have the entrance to the tomb. You have the left bench. You have the right bench. You have the back bench. I believe the body was on the back bench in the tomb because you remember John knelt down and got there first. He knelt down. He looked through the opening. Now, he was well back because he wouldn't be right up at the door because he has to let light into the tomb. Because there's no windows, there's no skylights, there's no electrical lights in the tomb. There's only light coming in through the door. So he would have been back from the doorway. He would not have had visibility of of the left or right benches, so that when he saw the burial cloth, that was on the back bench. Most people have never thought about that. And so then the location that I show on that diagram of the face cloth is my predicted location for the clay of where the face cloth I thought would most likely be, based upon the person doing the burial of just, without thinking, dropped the cloth to the right of his body, where his body was standing, because most people are right-handed. And that's the location, as it turned out, after I did the calculations. That was the location that gave the carbon date that agreed with the experimental measurements of the carbon dating of that cloth. So I'm doing something right.
Have you done a calculation on the left side with the face cloth?
Yes, my calculations did both. The area that's consistent with the right side is a little bit larger than what's consistent on the left. Now, so that there is an area on the left bench that also would date to about 700 AD, but it's a smaller area.
Okay, so both sides were around 700.
Well, yeah, so in other words, the sample location on the burial cloth down near the feet, up near the corner, was shifted in carbon date from 33 AD to about 1325 AD. But the face cloth was shifted from 33 AD up to about 700 AD. Why the difference? And that is caused because the face cloth was further away from the body. So that in every direction, the further you get from the body, the neutron density decreases. That's what the computer code says. So that up at the far end of the right bench, up near just right next to the entrance, the date for the shroud, for the face cloth, would have been changed maybe from 33 AD to 100 AD instead of 700 AD. So every position in that tomb would have changed to a different carbon date, no matter where the sample was located. Because the neutron distributions, the neutron densities are different. Neutron density would be neutrons per cubic centimeter.
Okay, so the closer it is to the shroud, the more younger it is, and then the farther away, the more older?
Well, yes, because you'd have less new carbon-14 produced on it for a sample that was further from the body.
Have you done any other tests, just the face cloth by itself?
Well, just the body cloth and the face cloth, but my calculations would include any linen sample location around the body or on the left or right side benches. Those are my previous calculations that I did in 2014.
I'm going to pull up something else I wanted to ask you about.
Okay.
This right here, these vials, would you be able to test these today and find anything meaningful with it?
Yes and no. Yes, if I was allowed to. No, if I wasn't. Right. So these samples, this material, in 2002, they did what they called refurbished the shroud. That was the term, refurbished. Other people have called it other things. But what they did was that they took off the backing cloth that was sewn onto the shroud in 1534 to help support it, and the patches that were also sewn on 2 years after the fire in 1532. But in 2002, they took that backing cloth off and the patches, 16 patches that were put on in 1534. They took those off. And what they discovered fully carbonated material, fully blackened material, fully burned material underneath those patches that they didn't know was there. So they broke that off and they put into small sample jars, as you see here, that were then put into the vault in Turin, Italy, and they've been there ever since. Now, the powers that be say, no, we don't want the shroud desecrated, therefore you can't test this material. But I think it's reasonable to argue this material has already been removed from the shroud. Therefore, testing this material doesn't really desecrate the shroud. Let's go ahead and learn what we can learn. Give us one bottle out of the, I think it's 42 bottles, yeah. And we can see what we can test.
Another question I have for you that
yes
is
excuse me. Let me just say a little bit more about this material and what would be tested.
Okay.
So that carbon dating could be done on this material, but also there would be a long-lived isotope that would be produced by neutron absorption, and that would be chlorine. Now, I kind of forget what, maybe it's chlorine 36 to 35, or is it the ratio of chlorine 37 to 36? I kind of forget right now. But that test would also be done because it's a very long half-life on that material. So that would then tell you the amount of neutron absorption at that location as a result of this neutron emission event in the tomb.
Now, Jesus, when he was on the cross, he was whipped with a flagrum. And, some people say, well, wouldn't his back just be really cut up really bad? So there would be like a pile of blood on the shroud on the back.
It would depend on the nature of the flagrum. Usually the flagrum would have 3 leather straps. It would be a circular wooden piece, maybe 10 inches or so, with 3 different leather straps attached to it, with the end of each leather strap then attached to an object. It might be a piece of bone, it might be a piece of glass. In this case, what it was little dumbbell-shaped weights, and that can be seen on the shroud. And then the issue is whether an object like that, little dumbbell-shaped weights, would have little spikes on it to actually cut the skin. And in this particular case, it's my understanding that they did not. So what was going on was that these weights, when they struck the skin, would not be breaking the surface of the skin, but would be causing subcutaneous bleeding. Okay, I think that's essentially the answer. No, we're not getting a lot of blood because it depends on the nature of the instrument that's being used. Also, another thing, often people talk about the tremendous amount of blood that is seen in, a victim in a car accident or something. Well, my goodness, there were certain types of injuries that were inflicted upon Jesus. And you have to realize that his hands were largely bound in one way or another. So though his scalp might be bleeding, the blood was not being spread by his hands.
What are some of the biggest misconceptions people have about the shroud?
Well, the main misconception is that the shroud is a product of the Middle Ages, and that's the carbon dating. The carbon dating is the main objection to the Shroud of Turin. Okay, now, let me just deal with other misconceptions about the shroud, and that's objections to it. There should be no objection to it. I mean, after people realize that it's authentic. And you can tell my attitude here that it really is authentic, and I have no doubt about it. For example, people say, well, one arm is longer than another, therefore it can't be authentic. It has to be a painting, or it has to be a forgery of some kind. Well, my response is, well, why would a painter or a forger make one arm longer than another? How can you explain that? No, that one arm longer than another proves it's not due to a painter or, painting or a forger. No, it's very simple. When he was crucified, one shoulder was out of the socket. Terrible process of crucifixion, and that creates things, evidence on the body that we just don't expect often. Okay, and one arm longer than another is simply one of those evidences. Let's see. Another evidence supposedly given. The two images are different heights. Well, my goodness. I bought a full-size image of the Shroud of Turin, and I tried to measure the height of the front image and the back image. And I actually couldn't do it, because the top of the head is not necessarily identified. And the feet may or may not be imaged as pointing downward, because in crucifixion, they were nailed to the vertical. So they would be in a downward pointed direction with knees folded. If you can imagine that. So that if you're trying to measure down to the bottom of the toes, well, that's wrong, because that's not related to his height. It would be the heel, from the heel to the top of his head, that's measured. Now, one of the other main objections here is that we have Catholic priests sending a document to the Pope, sometimes referred to as the anti-Pope. This was a time when there was more than one Pope in two different locations, 2 or 3 locations. And so, and this is said that the cardinal, I believe it was a cardinal, then sending this document to the Pope explaining that a painter has already admitted that he painted it. Well, there's no merit to that accusation. First of all, in many different senses. First of all, if there was, and there's no proof that there ever was such a painter. We don't know his name. We don't know who he was. We don't know where he was. We don't know when he was. We don't know how he did it. We don't know where he did it. We don't know anything about him other than part of one sentence, which the previous cardinal is alleged to have done an investigation, though there's no evidence for that at all. It might all just be rumors that he found an individual who admitted that he painted it. Well, what would he mean that he painted it? I mean, I could paint the shroud. I could go to the store and buy an easel and buy some paints and a brush, and I could paint the shroud. And I could tell that to someone, but I didn't paint the original. I painted a copy of it. Copies were commonly painted of the shroud. So maybe he was talking about painting a copy of the shroud to take back to his home church to show them. So, and probably, the many different reasons. There's no evidence that this document was ever sent because it was not found in the personal effects of this Pope. Okay? And there was not a single copy. There were 2 copies. Most of them were in museums, and they were both different from each other because they were both draft copies. There was no final copy that was ever made, according to the evidence. We have no evidence that there was ever a final copy. We have no evidence that it was ever sent to the Pope. Okay, that's where we have it. And finally, the STIRP analysis that was done in 1978. You remember what they concluded? There's no pigment on the shroud. Well, if the image is painted, there would be pigment on the shroud. So the STIRP analysis clearly proved under examination, high-powered microscopic repeated examination proved that there's no pigment on the shroud. Therefore, it's not painted. So if there's someone that said that he painted it, he meant something else by it. I doubt that there ever was such a person, because it could just be hearsay. The draft copies make no reference to any document regarding an investigation that was done by the previous cardinal. And certainly, the next cardinal would have referred to a document if he had ever found one. But he didn't. This was just hearsay.
Didn't Walter McCrone say that there was pigment on the shroud?
Well, he did, and that is. Give me a second here to get a book, okay? That is the main issue of this book. This is Report on the Shroud of Turin by Dr. John H. Heller, member of the Shroud Research Team. It was published in 1983. And the main topic of this is whether there was pigment from painting, a person painting the image on the Shroud of Turin. And so this gives the record of all the other individuals that was working on the Shroud of Research Team and the sequence of experiments that they did to determine whether he was right. And their conclusion was he was wrong. So in other words, there's two other sources of what might have appeared to be pigment on the cloth. One source is that many different individuals painted copies of the shroud. And after they completed such a copy, this was just the tradition, they would bring it up into contact with the original cloth, the Shroud of Turin, to transfer holiness, in a sense, and then take their copy away to their church to show their people back home. But in the process, you could have little fragments of paint then redeposited on the shroud. Matter of fact, I thought of three altogether. That's the first. The second is that when in 1978, when they brought the Shroud of Turin out into the open room in the right next to the cathedral, it would be in the Savoy Palace where they did this, which my wife and I have toured, by the way, in 2023. But the room was constructed with a wooden frame, and then they noticed that when you walked on it, little bits of paint would fall from the ceiling, which was painted. Okay? And it's, that was the habit in Italy. They painted beautiful scenes of multi-different colors, of course, on the ceiling. So you could get some little bit of paint falling from the ceiling just by walking in the room. The third, and I think maybe the most likely in this particular case, was that in the process of extracting the flax fibers from the stem of the flax plant, they would soak the plant in water, a stream, a pond, edge of a lake, whatever. They'd soak it for a long time, which allowed the rest of the plant to rot, and so that they could easily recover the long fibers that were 1/5 the diameter of a human hair. But in this water would contain various minerals, such as iron, so that in the soaking process, the iron could soak into the fibers, which is where he found little bits of iron, not from painting, because the paint would be on the outside of the fibers. So the conclusion in this book was it was probably the little bits of iron that was found, so little of it that it's almost, insignificant. The little bit that was found was probably due to soaking in the water to rot the rest of the plant. The other point is that this little bit of material was about the same concentration on the image fibers as the non-image fibers. So it wasn't related to making the images. So there's really no merit to this accusation at all.
In an interview I watched of you, and you were talking about the Hungarian Prey Codex, and I don't think I've ever heard someone say this, but you're talking about how Mary has a knife and she was holding the face of Jesus, and I don't think people pointed that out ever in that, which I thought was interesting.
No one else had. Yes, no, I believe no one else has. I'm the only one that I've ever heard say that, but to me it's obvious. And most people, when I say, "What do you see being held in her hand?" they say, "It's a side view of a face." Okay? Now, can I flip forward here a little bit? And okay, can you bring it back up again, and I'll show that.
Yeah. The one thing about the Prey Codex is that thing's kind of odd is they didn't put the full beard of Jesus on him. You know what I mean?
Well, Jesus probably didn't have a full beard.
Well, doesn't the Shroud though have a more of a defined beard?
It has a little bit. Some, yeah, he has a little bit of a beard.
Yeah.
So, okay. This is the coin that I have. A coin showing the front view. This is from 1025 to 1028. On the back, it says Jesus Christ, King of Kings. So it's clearly Jesus Christ that's being pictured there. The image is from the Shroud. And that disproves the carbon dating in and of itself. The emperor took his image off the coins and put the Shroud of Turin on. So it was extremely well recognized and highly revered. We've just forgotten about it now. Okay, look, there's so many different things here. Okay, so here is the Prey Codex. And the Prey Codex is just it's a document that's with not a scroll, but it's bound on the one edge like a book. So that's what a codex is. It's like a book. And that there were multiple. This was a large book, essentially a codex, but there were multiple colored line drawings, and this is one of them. And so there's two images here, which was typical in that day. They'd have an upper image and a lower image. And so the upper image is of the burial of Jesus. So you'd have three men. It would be the Apostle John. He was the only apostle left at the foot of the cross. And then Nicodemus and Joseph of Arimathea. And so you can tell which one is Jesus based upon the halo, or the technical term is nimbus, around his head. So Jesus is the one that's laying on the table there, or the bench, because he has the nimbus that represents Jesus. Okay, and then you notice in the back right corner of this upper view, you have probably Nicodemus, then, because he's younger than the other person on the left. Anyway, holding part of the cloth, which is long. You see him holding it with his left arm. He's holding a long cloth, so that this piece of cloth is a long cloth, and the Shroud of Turin is about 14.5 feet long. So that's what we're talking about. But it becomes much clearer what we're talking about here in the lower image, so that you have multiple different indications that this piece of cloth here is the Shroud of Turin. Now, I know there are individuals that say that this is not the Shroud of Turin, that this is actually the, what's the term? The tomb that he was buried in, essentially, like a coffin, a limestone coffin that he was buried in. But that's not true. This is the piece of cloth. We have several different indications. First of all, on this folded piece of cloth, you can see that the top section is folded back, but there is, it joins the bottom section that folds back from the bottom section along one edge, so that you can see the bottom and the top cloth. There on the bottom cloth, you can see it looks like a kind of a burnt sienna color. It was probably red, more reddish initially, a faded red color and a cross that would be representative of Jesus' blood on the inside of the cloth. You don't see that on the outside of the cloth, those red crosses, but you do on the inside of the cloth because the blood was primarily on the inside of the cloth. Now, the other thing that you see here on the top cloth is you see a stair-step pattern in the cloth on both the left side and the right side. You see a stair-step pattern, and that's because the 3-to-1 herringbone weave of the cloth can be simplified in that manner, in that pattern, but that this pattern is broken up in the middle. Now, if we could, let's see if I can get a closer view on that. There's a top view. Oh, there's this stair-step pattern on the Shroud of Turin that represents this 3-to-1 herringbone weave that's then reproduced on the top of this cloth on the Prey manuscript. By the way, it was discovered by a man named Prey. That's where it gets its name. Okay, let me just continue on here a little bit. So I want to try and find the stair-step pattern on the left and right sides of this top portion of the cloth is broken up in the middle, and in between the two, you can see a bunch of cloth. Those who say that this is not the burial cloth of Jesus say that this bunched up material is the burial cloth. No, this is just the remainder of what was resulting from something being removed from the top cloth. And you can see the knife that was used there on the top cloth at the top of the opening of this cloth. What was removed? Just look at on the 3 women to the right. The woman with the most notable nimbus or halo is on the left. This would obviously be Mary, based upon her nimbus, and on her on her right arm. That the artist here is a little bit challenged in his artwork, but her right arm is holding an object. And when you look at this object, you can see that this is the side view of a face, and that the beard is more significantly, the length of the chin is extended into more of a beard on the bottom of the image rather than on the top image. So there's the more of your beard. So that was what was removed from the top of the cloth by the knife that's visible is the face that was given to Mary. This makes sense. So what does that say about the cloth that we're talking about? That's what that says is that the image of Jesus' face was on the inside of the cloth that was cut away and given to Mary. Now, the people that say that this is just a coffin and not a piece of cloth, of course, don't want to admit that. But this is obvious when you just look at it. Okay, let me come down a little bit further. But maybe if there's any doubt about it, on the top cloth you can see a pattern of 3 holes. The middle arrow is pointing to them. There's a pattern of 3 holes in an L, 3 holes in a straight line, forming an L with a 4th hole to the left. So this pattern also indicates what this is. And you can also see these holes down on the bottom cloth as well. Not as clearly, though. You don't see the whole thing. Okay. You kind of see at least two different locations for holes, because on the actual Shroud of Turin, there are 4 locations where these holes show up, and there's a reason for that. So let me search for other evidence. Okay, this slide shows where those 4 holes are located. Now, in the upper left here, you have one arrow pointing to the 4 holes in an L-shaped pattern. Then the upper right arrow shows 4 holes in an L-shaped pattern, though the holes are not quite as large. The lower right arrow points to 4 holes with smaller diameters, and the lower left arrow points to 3 or possibly 4 holes. But these holes resulted when the shroud was folded up, okay? And someone, I think probably, came up with a sensor filled with hot coals, bent over a little bit too far to look more closely at this object, and dropped the hot coals onto the cloth, which then burned through the top cloth, then the second cloth, then the third cloth, then the fourth cloth, in sequence, leaving a series of holes in this particular L-shaped pattern in sequence. And that's exactly what's shown on the Prey Codex on the bottom image. So there should be no doubt that this is a piece of cloth rather than some kind of a coffin. Yeah, we don't know when this event happened. But
do you think the fire, though, could have changed the carbon dating in any way, like the smoke from the fire?
Well, if you had dated it without cleaning it, it might have. But they went through intensive cleaning processes. They took fabrics and boiled it in a mixture of acid and alkaline chemicals. The remaining material could have been less than 50% of what they started with. These were extreme cleaning processes, ultrasonic cleaning processes under temperature, under acid conditions. I don't think that there would be anything left from carbon from the fire. I don't think there'd be anything left from people handling it or wax or anything. And that's why they thought it would be reasonable to date this at that time. They knew that there had been a fire, but yes, it could be cleaned off. Now, on this picture that I'm showing, you see a little bit clearer. The knife has toward the top of the top piece of cloth, and this knife has. You can see the edge of the cloth. You can see to the kind of the upper left of the edge of that cloth. There's the handle, and to the lower right of that cloth is the blade. And so people wonder about why this blade has this little piece sticking out at the end. Now, I had never seen a cut-in item before with that type of construction until after I recognized this as the blade, and then I start looking for them, so that I now own 2 cutting instruments with this type of blade. And so what this is used for, this type of blade, that little extension on the tip of the blade is put there to assure that the blade does not come off of the item that you're cutting. That's the purpose of it. So there's a purpose to it, and that's the cutting instrument. And to cut the side of the face that you see. So the face was cut out of the top of that piece of cloth, thus indicating that this is the burial cloth of Jesus, consistent with the Shroud of Turin. Let's see if there's anything. Okay, there's a closer view of the 4 holes in the L-shaped pattern. Okay, and there's the cut-in knife, okay, with the arrows pointing to it, and the face. So you can see the nose with the mouth below it. You can see the eyebrow and the eye. And it comes down to the chin is extended to take into account the beard. Okay, so that you can see below there shows one of my cutting instruments with that type of a tip on the blade. So, and I also show an image of a modern fabric knife. Fabric knives are specially built for specific purposes. And so that's why you have this shape of the tip on that cutting knife. Okay. So there's the bottom image again. And I think that's it. Okay?
What are your thoughts on Nicholas Allen's photographic hypothesis for the image formation on the Shroud of Turin?
Yes, let me get another book. Hold on. Let me recommend this book to the readers. This is Test the Shroud at the Atomic and Molecular Levels. The author is Mark Antonacci. Was 2015. And he has a good discussion of this in multiple pages. If you get the more recent version, it includes the index. And so Allen is his name, is that right?
Yeah, Nicholas Allen. Yeah, I guess the theory is like a medieval photograph type of thing.
Oops. I don't find it right off. Anyway, he has several pages on this, analyzing it.
Mr. Rucker sent me an email after this interview and said that the rebuttal to Nicholas Allen's hypothesis is actually in Mark Antonacci's first book titled The Resurrection of the Shroud, which was made in the year 2000 on pages 84 through 85 and 88 through 89.
And it's just not realistic. It's not going to produce the microscopic evidence that's on the shroud. It's not going to produce, it doesn't produce not been shown to produce the macroscopic evidence that's on the shroud. The concept here that he's using is that the shroud, the full-length shroud, is mounted in a dark room, and totally dark, absolutely dark room. And in the wall, they have one little, very, a material, maybe a thin piece of metal or something. Today we do with a piece of aluminum foil, in which a very small hole is put. So then what happens is that the light comes through that hole and shines onto the cloth. And so what the person does who's trying to do this, puts up a dead human being, okay, hangs him up out in the sunlight for 3 or 4 days and hopes that there won't be thunderclouds or lightning or, rain or anything like that going on. That there'll be good sunlight for, 12 hours a day for over 3 or 4 days, so that the sunlight would always be going through that pinhole. This is a classic pinhole camera. And I've made one of these before in order to see an eclipse of the sun, for example. So the sunlight is coming through a pinhole, which then shines onto the cloth. But the cloth, if you just put a normal piece of cloth there, it would have no effect, because normal piece of cloth isn't sensitive to light, really, unless you have an exposure of, a month or 2 or 3. So that you'd have to put on some kind of light-sensitive chemical, probably a silver chemical. Well, no such chemical was recognized on the Shroud of Turin. And it just does, it's a good attempt, but you don't produce 3-dimensional image, information on the cloth. If you doused it with some kind of a silver compound, which was not detected on the cloth, then you would have capillarity. You'd have evidence of capillarity into the entire thread and across the entire fiber of your discoloration. But that's not the case. So there's every evidence against it. I do have one paper that I've written trying to consider some of these options for alternative image formation hypotheses. So, and I forget what number it is, maybe 35, 36, 37, somewhere in there. So that can be looked up on my third page over, research page on my website, shroudresearch.net.
There's a Bible verse in John, and some people interpret that verse as Jesus passing through the walls or doors of the room to appear to the disciples. And do you think that could be similar process with the neutron thing?
Well, there's no evidence that he passed through walls or doors or windows to get into the room. The evidence is that he simply disappeared. He either appeared or disappeared. It was just an instantaneous thing where the people saw nothing else of him, of his movement, for example. When he was talking with the two disciples on the road to Emmaus, you remember he went in with them? And when he went to break the bread for the meal, they recognized who he was, and he simply disappeared. He didn't get up and walk out of the room. He didn't make a transition through the wall. No, it was simply a decision based upon his spirit, his soul, his mind, to make a transition into an alternate dimensionality. Now, that's why in the New Testament, his new body after the resurrection, or as a result of the resurrection, was called a resurrection body or a glorified body or a spiritual body. Now, it's not a spiritual body in the sense of him being a ghost, and he proved that by eating the fish in front of them. But the word body, whether you call it a resurrection body or glorified body or spiritual body, the word body is the noun, and that doesn't change, but the adjective changes. So the way that I understand this is that the word spiritual refers to the essence of what was under control in his body, what his body was under control of. Now, the physical body would be under the control of the laws of physics as we understand them in our world. But in a spiritual body, the body is under the control of the spirit, so that by an act of his will, he could pop in at any location in our dimensionality. That's how I understand it, and I think that's the best option to explain it. Within taking into account what we know about science.
As I was preparing for this interview, this kind of reminded me of when Moses is described as having a radiant face after spending time with God on Mount Sinai, and the Israelites feared his presence, like his face. So I thought that was kind of interesting how, God is like this light that can't be really described.
Yes. Even a little bit more relevant would be Jesus' transfiguration, where he took on a glowing appearance, according to the observation, the observers that were there. So that, yes, but that's still not the same as what happened in the resurrection, I think. We'll never know whether there was actually a glowing of his face prior to the resurrection, because there were no observers in the tomb at that point.
Well, I'm just saying, like, he saw God, and that was some type of light too then. Not saying it's like the same. I'm saying it's the same exact thing, but just interesting. And your conference coming up, I forgot what date that was.
Yes, it's July 30th to August 3rd. It's a 3.5-day conference, actually. July 30th, we'll just meet in the evening, have dinner, and then just talk to each other.
And are you going to have like any new information for that one that you're presenting?
Well, yes. I'm hoping to have my calculations completed in order to, where I showed my subsamples. Yeah, I'm hoping to have that done.
So does that take like 6 months?
Yeah, I've worked on it probably 3 months so far, and I'm not done. This would be the samples.
Hmm.
So, I have to build the models. I have to understand what I want to do. I have to understand how to do it. Now, the input to this computer page, the theory and the input instructions to this computer code is 1,078 pages long. So maybe you can get an idea of the complexity of this just by the length of, what I have to understand in order to get this to work properly. And I may have to buy a new computer to do this. If I can't do it with my computer, which is about 4 years old, it's a quad-core computer, but the new Intel i9 has 24 cores, and the new AMD has 16 cores, and may be the better option for my purposes. So I may have to spend multiple thousands of dollars in order to get these results in a timely fashion. If that's necessary, then I probably won't have the results by the time of the conference, which will be a shame.
Do you have any like predictions 5 to 10 years from now, or like any testing that you would like to see on the Shroud in the near future?
Oh, yeah, certainly. The easiest thing is to simply test the samples in the jars. Or test some of the other samples that are available, like the ones down in the vault in Tucson. That's from the carbon date and the material that was carbon dated. This little piece has never been carbon dated, and carbon dating is a destructive process. But it's from the very sample that was cut for carbon dating. So that, yes, we can do carbon dating, we can do measurements of the calcium 41 to calcium 40 ratio in the limestone. I don't think I mentioned that, but that's a huge item. If we can get a sample of the limestone from the tomb, we test it for calcium 41 to 40 ratio, because that calcium 41 has a very long half-life. It's either 100,000 or 300,000. I forget which is which. Whereas the cloth, either the Shroud of Turin or the Sudarium of Oviedo, would contain chlorine, and there it's I think it's the chlorine 36 to 35 ratio that would be measured. And both of those either have 100 or 130, 100,000 year half-life or 300,000 year half-life. So you still have 99% of them existing. So that's what would be measured from my perspective. And then I would be willing to have material cut from near the elbows off of the current Shroud of Turin, because that's very close to where the cloth has been damaged. So let's make use of that fact. Let's cut a little bit more material, so then we know exactly where it came from. The material in the little sample jars, we may not know where it came from. Okay? So that, yes, there's a tremendous amount of additional testing that could be done. I guess there's a possibility of even using radiation detectors directly on the Shroud of Turin to determine what we see. That would be certainly a non-destructive test, and it would give us tremendous information. Same thing for the Sudarium of Oviedo. So there's a lot of very good testing that can still be done.
Who all has to approve like a test if they want to do it today?
Yes. Well, in 1983, the elder Savoy, last name was Savoy, he was very well-positioned political family in Italy. They had owned the Shroud for over 400 years. But in 1983, the elder Savoy, when he died, willed it to whoever the Pope is. So starting in 1983, it's been owned by the Vatican or the Pope. And so the Pope would have to say, yes, test it. Or he'd probably say, bring me a recommendation for what testing could be done. And then those recommending it to him would discuss all the options, and then he'd have to give his approval to the options that he was approving. So until the Pope approves it, it will not be tested.
Well, we do have a new Pope.
Yes. And when I say that would be of material that's under his control. Now, there is some material that's not under his control, and maybe that material could be tested.
All right. Mr. Rucker, thank you so much for doing this. I really appreciate it.
Mm-hmm. Well, I appreciate the opportunity to do this. I have talked up to 6 hours at one time on the Shroud of Turin.
We didn't beat the record then.
No, we didn't beat the record, but that was, I had prepared 6 different presentations, so we took a break in between the presentations. We had a 10 to 15 minute break between. But in 6 hours, I was only able to talk through 5 out of the 6 presentations.
That's a lot.
I didn't finish.
Where was that at? The 6 hour one?
Yes, that was in a church down in Tucson, I believe it was. Phoenix. So Lutheran church in Gilbert, which is a community in the south end of Phoenix. Yeah, so I was in person at that one. I just wanted to see how long I could talk, basically.